Hi everyone, we are back and we are going to start now. Oops, let me erase this. How can we think of ways to prevent corrosion? Oftentimes you're going to have metals or other materials in contact with one another. And that's just the nature of what we're going to have to deal with. Now, there's a couple ways. I could just add an insulating layer or a coating. So I could do basically a polymer coating or substitute a polymer material, right? Polymers are much more adept at avoiding, and basically they're not corrosive, or they're not going to corrode at a rate that's similar to metals, for example. But there are a couple other ways we can do this. One is we can use cathodic protection. So this is simply we're going to basically impose a current to force electrons to flow in the desired method, or the desired direction. So for example, let's say I have a material, I have material A and material B, and material B is the electrons are flowing to material A. To prevent this material from corroding, I could actually inject a current into B to prevent that material from corroding. So I can just run a current through that material to protect it. So that would be cathodic protection. Another cooler approach is a sacrificial anode. So let's look at the following scenario. I actually have three materials that are connected. So let's say we have Cu, which is 1.9 electronegativity. We have Fe, which is 1.83, and we have Zn, 1.6, what was it? 1.65? Electronegativity, yes. So, in this scenario, obviously this material is going to corrode. Actually in this scenario, this material is going to corrode. So actually, let's say, for example, before we even do this, zinc, I have this setup. We know that electrons are going to flow from iron to copper. If I want to protect iron, I need to connect another material that has an electronegativity lower than this. So 1.65 zinc. Now, zinc is going to, or copper's going to grab electrons from zinc, and iron's also going to grab electrons from zinc. Excuse me. Oh, apologies. Today is the day of sneezing. Now, you may ask ourselves, well, wouldn't iron also corrode? Well, copper will pull electrons from iron, but iron's also pulling electrons from zinc, plus copper is going to pull electrons from whatever's easiest. So it's much easier to pull electrons from zinc than it is to pull from iron. So in this way, we are including a sacrificial anode. Zinc is the sacrificial anode material that is going to corrode to protect the anode material that we don't want to corrode. So we're protecting iron by adding in another anode that has a lower electronegativity. So that's a cool method to basically prevent corrosion of a material of interest. So that is it. So good luck on your PSET 8, and we'll see you then. Bye.